Population of deer in a 100-acre enclosure varies according to this sinusoid. T is time in months, and pi over 6, if we take the period, equals 2 pi over b. B is pi over 6. Pi's cancel. We get multiplied by 6 and 2, so that we get 12. So the period is 12 months, and so that makes sense. That's going to be, like this. Is plus 800. So it's going to go up and then down and up and back for a sine function. And what is the approximate date you expect the deer population to reach 1500? That's going to be somewhere up here. This is at 800, so somewhere up here at 1500. If there were 800 deer on January 1st, of course, you plug in times 0, you get sine of 0 is 0. The whole thing becomes 0, and you get 800. So that's just where it starts at with the sinusoid as at 800. So saying we go from January 1st, and then it fluctuates like this. And the maximum would be, right, sine can output a maximum of 1. So this would be 1 times 750. 750 plus 800 is 1550. So actually the maximum, the highest point here is at 1550. So there's actually going to be 2 points where we expect the deer population to be at 1500. And when we solve this, we're going to get the first point. We have to keep that in mind for the solution. Okay, so let's go ahead and plug this in. 1500 is the population. 750 sine pi over 6 t plus 800. So I'm going to subtract 800, then divide by 750. That gives me 70 over 75. So divide by 5 is going to be 14 over 15, I believe. Sine pi over 6 t. So I just need to take the inverse sine and then multiply by 6 over pi. So 6 over pi times inverse sine 14 over 15. I definitely know there is a solution. 14 over 15 is less than 1, so it's going to be within the sine. So plugging that into a calculator. Let's see, 14 over 15. Yep, and that gives me 2.30 approximately. So it's going to be 2 months past January 1st. 2 months past January 1st is going to be March. And then 0.3, that's about a quarter or a third of the way through a month. It's going to be about 10 days. So March 10th sounds correct.